Hi, today we'll be looking at faster FPT algorithms for deletion to pairs of graph classes. So we'll be looking at vertex deletion problems where you have a graph G and integer k, and the question is, can we delete some k vertices such that the rest of the graph belong to some graph class pi? So this covers popular examples such as vertex cover, feedback vertex, etc., where the graph class pi is an edgeless graph or forest, etc. So there is a whole notion of forbidden family associated with graph class pi, which is a collection of graphs such that a graph is in graph class pi if and only if it does not contain any member of F. For example, a graph is a forest if and only if it does not contain any cycles. And this forbidden family can be finite or infinite depending on the graph class. So we'll be looking at designing FPT algorithms to graph problems. So let's define what it is. Here we have also an integer, a parameter k associated with the input, and we want the algorithm to run in f of k times polynomial in input. In such, it is the case we call the algorithm as fixed parameter tractable algorithm. We'll be looking at this notion of scattered graph class, where each connected component of the graph is such that it belongs to some graph class pi1 to pi d. For example, in the picture, we have a graph where four components of a graph, where the first component is a tree, second component is an interval graph, and third component is bipartite, fourth is a tree. So this is a scattered graph class where the graph classes are tree, interval, and bipartite. And we are looking at the vertex deletion problem corresponding to this scattered graph class, where you delete some k vertices such that the rest of the graph is such that each connected component belongs to one of the graph classes pi a at least. So a previous result by the set of others showed that pi1 by d vertex deletion is FPT if it satisfies the two conditions where the individual pi a vertex deletion problem is FPT and the property that a graph belongs to pi a is expressible in CMSO logic. Unfortunately, the running time of this is very huge, and we look at this special case where each of the graph classes pi I is characterized by a finite forbidden family. But even in that case, we only managed to show that the running time of the algorithm is 2 power poly k, which is actually pretty huge. Hence, we are looking at in this presentation special pairs of graph classes and hope to obtain very faster algorithms for these cases. And we do manage to show this for a numerous number of problems. And so the general definition of pairs of graph classes pi1, pi2, and let's look at an example where pi1 is claw-free graphs and pi2 is triangle-free graphs. So hence, if a graph does not satisfy this claw-free or triangle-free, then there is a component such that it is neither claw-free or triangle-free. Hence, there is a claw C and a triangle T occurring in the same component. And since they occur in the same component, there is a path P between them. The solution has to hit the union of C union T union P. We look at such a CT pair such that the length of the P between them is the shortest among all the pairs. And we notice that then when you look at the neighborhood of this P, there does not exist a vertex V which is adjacent to an internal vertex of P. We managed to show this. Since that is the case, we can then conclude that there is some solution which intersects C union T. Hence, we can just branch on the vertices of C union T, and C union T is finite. Hence, this branching algorithm gives a 7 power k algorithm, whereas claw is a triangle union, there are only 7 vertices. Then we managed to generalize this idea to a lot of pairs of graph classes satisfying these three conditions. We don't go into that, but the idea is these conditions allow us to branch on these pairs of graphs, and after that we can just apply algorithms corresponding to the individual deletion problems. And these are the examples that covers our algorithm. So we managed to give faster FPT algorithms, and we also managed to give good approximation algorithms for these pairs of graph classes. And the open problem is to find kernels for these kind of scattered graph class deletion problems. and to obtain faster algorithms for other examples. Thank you.